Hello there. We are going to discuss a series of articles 125, 126, 127, 128, and then go back to easy articles 123 and 124. Uh, these are all immediate consequences of Article 122. So, in trying to discuss each one, we will always go back to Article 122, okay? And this is the Article 122. So, Article 125 is a theorem that says that if a variable triangle has a fixed base, this is our fixed base, BC, and a fixed circumcircle, this is fixed, then the tritangent centers of the triangle describe two circles passing through two fixed vertices for having for centers the extremities of the circumdiameter perpendicular to the fixed base, to the fixed side. Seems to be too wordy, but what it tries to say is the fact that we have a fixed base here, BC, and A is just dependent on this circumcircle, okay? And we know that for as long as we construct a circle that passes through B and C, then A will always be dependent on this circumcircle, okay? So that's what it is. So it would be best that we go back to Article 122. And this is Article 122. And there are 6 circles, the 3 red circles and the 3 blue circles. And then we determined the circle. Okay, it would be best that you go back to my previous discussion of Article 122 so that you would fully understand what this is all about. But since we are only interested in base BC because this is fixed, so we need to examine circles that pass through both vertex B and vertex C, okay? This smaller blue circle passes through vertex A and B and not through C, so let's hide this. Okay, this particular circle passed through A and C but not B, so we need to hide it too. This is the circumdiameter. This one passes through A and C, so we do not need it right now. And finally, this one passes through A and B but not C, so we will hide it. So here are the things that we've got. So in this particular blue circle, let's hide this. In this blue circle, it passes through points B and C of triangle ABC. That's cool. But the diameter is determined by in center I and x center I sub A. That's one. But we also know that this diameter passes through the circumcircle at point K, and this is actually the center of the blue circle. On the other hand, this big red circle passes through points B and C, and A is not affected, just like the blue circle, A is not affected. And this one is determined by x center I sub C and x center I sub B. And that's the diameter of it. And the center is the midpoint, and it is on the circumcircle K prime. Okay? And KK prime, as we all know, is the diameter of the circumcircle. So, having remembered that, we can go back to our problem and say, wait a minute, this is my fixed base. A can be anywhere, so I can just construct the line perpendicular to BC, and definitely it will intersect the circumdiameter at K and K prime. And I know that these two are the centers of the circle. So all I need to do is to construct a circle with center K and radius BC, BK or KC. And another one with center K prime and radius BK prime or CK prime. And that's it. No matter where A is, this big red circle and the smaller blue circle will always be determined, and that's what the theorem is all about. This time for article 126, this is another immediate consequence of article 122. The midpoints of 6 segments determined by the 4 tritangent centers of a triangle lie on a circle, namely the circumcircle of the triangle. Well, going back to article 122, we have the 6 circles determined by the 4 tritangent centers. So we have the 3 red circles and the 3 blue circles. The first one is this one, okay? This particular circle has diameter I sub A, and we know that it passes through this particular center, which is point K, and it lies on the circle O, okay? And that is IK is equal to KI sub A. That's for the first one. And it lies there. The next one is, again with center I, and then this time it's I sub B. So this is my diameter, and that is this blue circle here. The center is L. And the last but not the least for the blue circle is this one. And it again passes through diameter I sub C, and its center is point M, which is on the circumcircle. These 3 points, K, L, and M, are the minor arcs determined by the circumcircle. The remaining 3 other points are based on the major circle. So instead of K, we have major arc BC, and its midpoint is K prime, and that K prime is the center of the circle with diameter I sub C, I sub B. For L prime, it is determined by diameter I sub C, I sub A, and this is the center of it, and therefore it is passing through A and C. And last but not the least, M prime is the center of the circle with diameter I sub B and I sub A. So we have 6 points on the circumcircle. The circumcircle, points K, L, and M. These are the midpoints of the major of the minor arcs, and K prime, L prime, and M prime are the points on the major arcs. And we also know from article 122 that KK prime is a diameter, LL prime is another diameter, and KK prime is a diameter. Furthermore, IK I sub A is are collinear to each other, and K is the midpoint of I sub A, or the diameter I sub A has midpoint K. The diameter I sub B has midpoint, has midpoint L. And finally, the diameter I sub C has midpoint M. And then here, K prime is the midpoint of segment or diameter I sub B, I sub C. L prime is the diameter of I sub A, I sub C, and M prime is the midpoint of diameter I sub A, I sub B. That's all. Now let's go back to articles 123 and 124. These are just simple and immediate consequence of Article 122. Okay, so Article 123 is a theorem that says the four tritangent centers of a triangle lie on six circles, which pass through the pairs of vertices of a triangle and have for their centers the midpoints of the arcs by the respective sides of the triangle on each circle. We know that for every triangle, there are four centers, okay, based on the angle bisectors, the in center I and the three X centers I sub A, I sub B, and I sub C. If we take out of four objects, if we take 2 points at a time, then there will be six possibilities. And that's the reason why it's I sub A, I sub B, I sub C, I sub A, I sub B, I sub A, I sub C, I sub B, I sub C. These six different things will determine the diameter of the circle that is being mentioned in this particular theorem. Okay, so going back to the uh, Article 122, okay, with respect to point I or in center I, there are three circles that passes through it. Okay, the three blue circles. The first one is this one, and it's determined by I sub A. The next one is this big one, determined by I sub B, and the smaller blue circle determined by diameter I sub C. And the respective centers are points K, points L, and point M. All of them lie on the black circle, which is the circumcircle of the green triangle, okay? Or the yellow triangle. For the red circles, these are all that passes through, say here, I sub B and okay, sorry, I sub B and I sub A. And the center of this particular circle is M prime, and the diameter is I sub A, I sub B. The next one is K prime. K prime lies on the circumcircle again, and this is the center and the midpoint of diameter I sub C, I sub A. And last but not the least is this big circle here with uh, center K prime. And the diameter associated with it is I sub C, I sub B. And that's what the theorem is. Very easy. And last but not the least is a corollary that if we are given the six midpoints of the arcs subtended by the sides of a given triangle, triangle ABC, on its circumcircle, then the tangent centers of the triangle may be constructed by using compass alone. So by constructing circles alone, we will be able to determine the four tritangent circles, okay? So let me hide the center first. So this is triangle ABC. I can change that, etc., etc. And the midpoint of arc BC. Okay, let's try to hide this one. There we go. Okay, yes. Okay. So the the midpoint of arc BC is point K. The uh, midpoint of arc BC, the other side, or if you say major arc BC, is K prime. We know that KK prime is also a diameter. Next, L is the midpoint of arc AC, and M is the midpoint of arc BC. And then the midpoint of major arc AB or ACB is M prime, and the midpoint of major arc AC or arc ABC is L prime. So all these 6 points are given. Then the corollary says that we can locate the three excenters and the incenters. Well, if I construct circle K, okay, that's circle K. All I need to do is construct circle K. The radius of circle K is either BK or CK. Next, construct circle L. And circle L will be, the center will be L and the radius will be LA or LC. And last blue circle is circle M. Circle M, the center is M and the radius is either MA or MB. Next, construct circle K. What would be that? That circle K prime will be this one, and the radius will be K prime C and K prime B. Okay? And then construct circle M prime. And how we do that is either using radius M prime A or M prime B. And last but not the least is circle L prime. And circle L prime is L prime. The radius is, okay, the radius is L prime A or L prime C. And these are the 6 circles, and this, where the 3 blue circles intersect, that is the incenter eye. And now this will be one of the excenters, this will be the other excenters, and this will be the third excenters. Okay? And that's I sub C, that is I sub B, and that's I sub A. And that's what the corollary is all about. Okay? Like, we only constructed circles. Thank you. This time we finally consider articles 127 and 128. The product of the distances of two tritangent centers of a triangle from the vertex of a triangle collinear with them is equal to the product of the two sides of the triangle passing through the vertices considered. A little bit wordy, but if we scrutinize it, it's not that difficult. So let us consider, so there are 6 circles here. Let us only consider one of them, and it is the circle with diameter I sub A, okay? And that's the circle that passes through it. And definitely, I can even consider extending it, and I know that this is an angle bisector, actually an internal angle bisector, okay? And then, well, what it says here is that the product of two tritangent centers, so that's I and I sub A, with vertex A. So AI, I sub A is equal to AB times AC. Okay, let's try to check if that is really the case. So let's consider AB, find the measurement of this one, and that's 9.33. AC is equal to 13.59. And then let us consider AI. And finally, I sub A. Okay, that's the distance. And let us find the corresponding products. AB times AC, that's equal to 126.83, and then AI times I sub A. Oh, indeed, they are equal to each other. Very cute indeed. Okay, and as I drag this one of the vertices, it's always the same thing. Okay, so however, to prove this, it seems that the only thing that I need is the power of a point theorem. Okay, and let us recall the power of a point theorem. P can be located inside of a circle, or P may be inside a circle. But no matter what, the power of point P, which is equal to the product of PA times PB, uh, PA times PB is equal to the product of PC times PD. And you notice in this case, PA times PB is equal to PC times PD, and both of them are equal to 1/4. If P is inside the circle, the product now is equal to 29.01, and it's also the other one is 29.01. So whether it is inside or outside or even on, when it is on, the product must be equal to 0. Okay, this is almost 0, but I can change that. Anyway, so the product of PA times PB is equal to PC times PD. Wow. Okay. Now, let us consider that particular power theorem. So, here's the thing that we've got in here. So, I want to name first this particular point, and this particular point, since it is along here, let me call this one B prime, and let me call this one C prime, okay? There you go. Now, then definitely this times this, so the power of point A. So, the power of point A will be AB times AB prime is equal to AI times AI sub A. But that's also equal to AC times AC prime. Cool. However, this AI or I sub A is the diameter of the circle. And since this is the diameter and angle 1 is congruent to angle 2, then definitely this particular ray AB, is reflected on this ray and it becomes ray AC. So they are reflections of each other. So in that case, AB is equal to AC prime and AB prime is equal to AC. AB is equal to AC prime and AB prime is equal to AC. Hence, in this particular equality, I will replace AB prime by AC. AB prime equals AC. And hence, we have the theorem itself, which says that the product of AB times AC is equal to, okay, so this should be AB times AC, okay? AB times AC. AB times AC is equal to AI times AI sub A. That's very cool. If we summarize it, here's the thing that we've got. So again, we know that this one, AI times AI sub A is equal to AB times AC. And that's the same true for this one as well. Okay, so that is now, okay, so power of point B now is equal to BI times BI sub B. Oh, this should be I sub B. I sub B. There you go. Okay. BI times BI sub B is equal to BA times BC. That's this line here. Next is power of point C. Okay, so this time is power of point C, so that's this one. Okay, so, okay, sorry, not that one. It has to be this one. There you go. Okay. So power of point C. Let me hide this. Let me hide this. And I only have this. Okay. So power of point C tells us that I sub C. Again, I need to correct this. To I sub C is equal to CA times CB. That's very good. Oh, I need to correct this one too. So now I have this other red circle here. Now this red circle is a little bit different because it's now B I sub A times B I sub C is equal to BA times BC. Okay, so that's this line here. You notice that the product is equal to 102.58 even if I change this one, okay? So the product will always be the same, okay? So this is with respect to the power of point B where B is inside the circle. Okay, so IA, IC. So now let us consider this one. So that one now is a power of point C. So that's this one. Power of point C will be C I sub B times C I sub A is equal to CA times CB. That's this one. And the product is always the same. Okay, 154.3, 154.43. Okay, so that's the power of point C. Now let's consider the last one, the power of point A. Okay, this one. So this is now AB times AC. AB times AC is equal to A I sub C times A I sub B. Okay? And the product is 113.8. So putting them all together, that's all. Okay? That's very cute. And we have the other theorem. And those are the 6 circles. And these are the powerful results of it. Let's put it here. That's very, very good. Let us observe that, okay? The internal bisector and one external bisector lie on the same side of the corresponding angle, meaning to say with A, I and I sub A are on the same side of this particular point A, whereas I sub B and I sub C lie on opposite sides of A. Okay? That's what this observation is. And that's very, very long, but it's very beautiful, don't you think? Thank you for listening. See you again next time.